I welcome you all to this week 3 lecture 3. It is overall conclusion of FET RC coupled amplifier. So the overall voltage gain AV is equal to AV mid frequency voltage gain divided by 1 plus J F by F21, 1 plus J F by F22, 1 minus J F11 by F, 1 minus J F12 by F, 1 minus J by F13 by F. So numbers are given 1, 2, 3, 4, 5. 1 and 2 are cascade of low pass filters. The first low pass filter is because of input side internal capacitor. Second low pass filter is the output side internal capacitor. So and F2 is equal to minimum of F21 comma. And the third and fourth and fifth, they are cascade of high pass filters. The first high pass filter corresponds to the input side coupling capacitor. Second high pass filter corresponds to output side coupling capacitor. Third corresponds to source bypass capacitance. Cascade of LPF, cascade of HPF. So F1 is maximum of F11, F12, and F1. This is overall conclusion of FET RC coupled amplifier, similar to that of BJT RC coupled amplifier. So we'll consider it with an example and do the calculation for this also. So mid frequency voltage gain is minus GM RL dash. All the values are mentioned here. GM is 5 milliampere per volt. CGS is 1 picofarad. CGD is 0.1 picofarad. CDS is 0.5 picofarad. Small r the internal resistance is 100K, and FT, the gain bandwidth product is 15 megahertz. Mu is 500. Mu is actually GM multiplied by RD, that value is 500. And RG is 1 mega ohm. RV is 100 ohms. External resistor RD is 4.7K, and load resistance is 10K. And first computation is RL dash is capital R parallel with capital RD parallel with RD. That is 10K parallel with 4.7K parallel with 100K leads to 3.1 kilo ohm. So AVMF is equal to minus GM RL dash. GM is 5 milli multiplied by RL dash is 3.1K. Answer is minus 15.5. Is the mid-frequency voltage gain. Clearly visible is that the transconductance of FET is very small compared to the transconductance of BJT. That's why the gain of BJT amplifier is generally considered to be high compared to FET amplifiers. So F11 is equal to 1 by 2 pi Cc Rg plus Rv. 1 by 2 pi Cc is 0.1 microfarad, that is 0.1 into 10 power minus 6 multiplied by 1 mega ohm. And making the calculation, F11 is 1.5 H. Most very small, 1.5 H. Then F12 is equal to 1 by 2 pi Cc small RD parallel with the capital RD plus RL. So substituting this here, 1 by 2 pi 0.1 Cc value is 0.1 into 10 power minus 6. RD parallel RD is 4.48K. Load resistance is 10K. Computation, the answer leads to 107H. 07H. This is F12. Similarly, F13 is equal to 1 plus mu divided by 2 pi Cs RD parallel R plus small RD. So mu value substituted 500 becomes 501, 2 into 3.14. Cs is 47 microfarad. RD parallel RL is 3.2K plus load resistance is 100. The answer will be computation 16.7. So F1 is equal to max of F11 comma F12 comma F13. Answer is F12 which is 107 H. This is coupling capacitor at output side. Okay. Next, F21 formula is 1 by 2 pi C1 Rg parallel Rb. Rg parallel Rb is always Rb. Rg is 1 mega ohm. Rb is 100 ohms. And C1 is equal to CGS plus CGD plus 1 plus GMRL dash. So GMRL dash is already computed. We substitute here 1 pico plus 0.1 pico into 1 plus 15.5. The answer is 2.65 picofarad. Substituting on the values 1 by 2, 3.14, 2.65 into 10 power minus 12 and Rg parallel Rb is 100 ohms. Substituting this gives answer 600 megahertz. Computing the second, that is output side internal capacitor based coupling based cutoff frequency. So F22 is equal to 1 by 2 pi C2 into Rn dash. So Rn dash is a parallel combination of all these. We calculated this 3.1. C2 is equal to CDS plus CGD. 0.5 picofarad plus 0.1 picofarad. The answer is 0.6 picofarad. Substituting these two values into this equation, F22 is equal to 1 by 2 pi 0.6 p, that is picofarad is 10 power minus 12 multiplied by 3.1 k. The answer is 85 megahertz. So overall upper cutoff frequency F2 is minimum of F21 comma F22, out of which the minimum is F22. So 800 megahertz, sorry, 600 megahertz, 85 megahertz. Out of these two, 85 megahertz is the minimum, 85 megahertz. So bandwidth is equal to F2 minus F1. F2 is 85 megahertz, F1 is 107 hertz. So approximately the bandwidth is 85 megahertz. So that's all the week 1, 2, 3 lectures corresponds to the single stage FET RC coupled amplifier, single stage BJT RC coupled amplifier, calculation of its band. Next lecture, we'll see the analysis of multi-stage amplifiers. If more than one stage is connected, cascaded of one after other, more number of amplifiers are there, multi-stage amplifier. In that, we'll see how specifically the overall voltage gain, current gain, input impedance and output impedance is not there in syllabus. We will go for lower and upper cutoff frequency calculation and so the bandwidth calculation. Thank you for this. Next we will see the multi-stage amplifier.